Hi friends, you must have heard or used tools like Cursor, Cloud Code, ChatGPT, especially with the recent rising popularity of OpenCloud and CloudBot. There's also a corresponding rising anxiety of people fearing that they will lose their job. Today, let's do a deep dive into what build an AI agent. Let's get started. So, what makes an AI agent? Agents are like humans. Essentially, you have your brain that does the reasoning and tells you what to do. But also, you need to interact with the world with your input and output and turns your words into action. That's why you need tools. Besides, you need memory. You cannot need to remember what you have done and what you haven't done yet to avoid duplicates and also absorb new learnings. And lastly, you need a loop to understand what to do next. So on a high level, we need these four components. We need the brain, essentially the foundational models. We need the tools. You can think about how we convert the language into action. We also need memory to be consistent. And lastly, we need a loop, feedback loop, to understand what to do next. So let's start with the brain. Essentially, brain is about the foundational models. It takes text as input and output text. So text in, text out. And there are mainly two categories of the foundational models. One is the closed-weight models. As you can see here, we have GPT models from OpenAI. We have cloud models from Anthropic. And then we have the Gemini models from Google. So these closed-weight models, as you can see, many of them are commercialized models. And we also have open weight models, which means that these models you can host on your own using tools like VLM. There are pros and cons on this. You have more control on how you want to inference. You can also fine-tune the model and use your own infra. So essentially, you don't need to pay per token. You use your own infra. But with this closed weight model, they only expose the API to you. So you need to pay per token. And then let's talk about tools. Tools essentially is how the agent convert words to action. So you can think about that. If I want to check out someone's PR, I need to connect or have access to GitHub. And GitHub is a tool. How do you connect between an AI model that has only text in and text out to accessing and giving command to GitHub? You need things like MCP. The MCP stands for Model Control Protocol. You can think about as a USB-C connector that connects the foundational models with downstream tools, such as what we talk about, GitHub, Jira Ticket, Slack, etc. So MCP is quite standard and model agnostic. But you can also build customized tools specialized for certain models or certain tools. And next, most interesting part, and also remains still a challenge in this industry, is about the memory. So you must have heard about this context window concept. Beyond a certain context window size, the model cannot memorize. So when you're in a chat with ChatGPT, ChatGPT has its own short memory. For example, 120K tokens. Within that, it can still memorize what you are talking about. But beyond that token size, it does not know what you're talking about. It will be forgetting. So one level deeper in that, we have this working memory. So this is more agent specific. So you can think about this as a state machine. So for example, when you are using Cursor, the Cursor coding agent has to remember what files it has changed and what files it hasn't. So this working memory can extend beyond the context window. And lastly, the most long-term is the model or the agent's knowledge base. So for example, when you are using ChatGPT, it has memory that stores certain things about you. And when you are using Cloud Code or you are using Cursor, there's a root level folder that can store something about their knowledge. For example, the .cursor rules folder and the .cloud folder. Given a task or given a question, how do you load the most relevant long-term memory is pretty crucial and important for the agent performance. There are some existing tools on this, And also, this is a big developing area for AI agent. And next, we talk about the loop. Essentially, you can think about agent convert the language into action and interact with the world, and then it will get feedback. So what do they do next? This is what you need to define in the loop. So here is a concrete example in Andrej Karpathy's project called Auto Research. You can look at him defining the feedback loop for the agent. Essentially, he's saying that you start with an experiment idea, and then you run the experiment, read out the results, and given the result, commit the code or not. And essentially, he's also defining that never stop and keep iterating this so the agent knows what to do after they get a result. So Andrej Karpathy defines this feedback loop in plain English language. And in order to build your own agent, you can also use these developed tools, the SDKs. There are agent SDKs built by big tech companies that allows you to define the feedback loop and define the action, prompting, orchestration. It's a whole tech kit you can use to build your agent. There are also some independent frameworks here. So with that, we covered about one single agent. But recently, there's also a trend of orchestrating multiple agents so that each agent can specialize and collaborate. So for example, like Crew AI, it has role-based agent can collaborate with each other. So this actually reminds me of Kubernetes. With Kubernetes, you can orchestrate multiple compute nodes. And now with multiple agents, we also need a way to orchestrate. So, but orchestration is not always necessary. You can always spawn multiple agents in your regular day-to-day tools like Cursor or Cloud Code. It's actually simpler and more practical. So that's it for today. We have covered the major components of one single agent, including its brain, the foundation models, the tools usually built by MCP, and also memory, the working memory, short memory, and long-term memory, and also the feedback loop that link everything together. So that's it. Thank you for watching. I'll see you next time.